Assalamualaikum and good day to Mr. Halim, my module leader for Risk Theory, and to all the viewers of this video. So today I'm going to explain question number 4 by using Excel. So question number 4 states that the number of claims n is a negative binomial distribution with mean 6 and variance 12. And this statement is actually wrong and it is replaced with suppose that the distribution of m where probability m equals to 0 until m equals to 7 as follows. We can let s is equals to m1 minus 1 plus and then add with m2 minus 1 plus and then add with m3 minus 1 plus until m equals to 8 until m8 minus 1. So by using recursive method, compute the probability that s is more than and equals to 10. So the information that can we extract here is n is the frequency distribution, number of claims, and it is given as a negative binomial, and their mean and variance is also given, which is 6 and 12. And then the probability of m is the severity distribution, where it is a discrete distribution in this case. And then the s, which is the aggregate losses, we can see that it is in the form of payment, where m1 minus 1, m2 minus 1 plus, m3 minus 1 plus are all in the form of x minus d, which is the d is the deductible with the value of 1. And then by using recursive method, we have to use the recursive parameters a and b to compute the probability s is more than equals to 10. First of all, in Excel, I extracted all the important informations from the question where n follows negative binomial distribution and the expected of n is equals to r beta, which is equals to 6. And then the variance of n is r beta, beta plus 1 equals to 12. So since I have the value of r beta is equal to 6, I can find the value of beta plus 1, which is 12 divided by 6 equals to 2. Then the value of beta is 2 minus 1 equals to 1. So when the beta value is 1, of course the r value here becomes 6, where 6 divided by 1 is equals to 1. Then I can find the value of a and b. For negative binomial distribution, a is equals to beta over 1 plus beta. In this case, it's 1 over 2, 0.5. And b is equals to r minus 1, beta over 1 plus beta. So it is 2.5. Then I extracted the discrete distribution where m is equals to 0 to 7 and the probabilities are as follows. So as we see in the question, it is in the form of payment, as in the form of payment. So we can actually decide whether we want to use y, which is the payment per loss, or z, which is the payment per payment, in order to find the final answer, which is probability the aggregate losses more than equals to 10. So D in this case is equals to 1, which is the deductible just now. And to find the size of payment, of course, we have to make sure that the deductible is lesser than the value of m in order to have a non-zero size of payment. So in this case, m is equals to 0, which is less than the deductible. So there is no payment. And when m is equals to 1, when we minus the deductible, of course, the size of payment is equals to 0. And this follows for all the other formulas, where 2 minus 1 until 7 minus 1, we will have y as the new size of payment, which is from 0 to 6. So when we use y, we can approach until NL. So whenever we use y to calculate the payment, we can tell that we can approach NL and change the distribution to NL distribution. But if you want to use Z, which is the payment per payment, we will approach to ZNP, where we have to revise our negative binomial distribution to NP revised distribution. So what is the probability of Y? It follows exactly like the probability of M, but just for this 0, since it takes both the probability of M equals to 0 and M equals to 1, so we have to take the value of 0.8, which is 0.65 plus 0.15. and the other probability follows exactly same like the probability m equals to m. But for probability z, which is payment per payment and also known as a non-zero payment, so when the size of payment is equal to 0, the probability here is equal to 0. So modification for the probability must be done because this 0.8 now has become 0. So the total probability balance here is actually 1 minus 0.8, which is 0.2. So what we have to do to find the probability of z is actually take the initial probability of y divided by 1 minus 0.8. And when we do this method for all, we can get the probability of z, and we can check it if it is correct or not by using the sum functions, which is this. So we get the sum is equals to 1. So our probability of z is correct. So in this question, I use NP in order to compute this answer, where there will be a new distribution for NP, which is also a negative binomial. In this case, the understanding of coverage modification is very important because when we change the value of m here to y and also the z, so we are changing the frequency distribution, which is the negative binomial n to negative binomial np. So frequency distribution modification always comes with the modification of the parameter as well, where we will be multiplying the value of beta with v, but the value of r will be the same as the previous one. So we can see here our r star is equals to r is equal to 6. Meanwhile, our beta star is equals to v times beta. So what is actually the value of v? V is the value of probability of paying a claim, where in example, when the severity is more than the deductible. So in this case, to calculate the value of v, it's very easy. It's 1 minus 0.8 here because y equals to 0 is not included in our NP. When we use z, we use NP. So in NP, we will not include y equals to 0 because it is a non-zero payment. So 1 minus probability y equals to 0, we will have 0.2. So 0.2 is the value of v. And when we times with the beta, which is the original beta equals to 1, and we will get 0.2 times 1 is 0.2. So from this new revised parameter of negative binomial, so we can actually get our new value of a, where a for negative binomial is 1 over 1 plus beta, and b for negative binomial is r minus 1, 1 beta over 1 plus beta. Okay. So now we have all the informations for the NP, and we are using these values in order to compute the probability of s equals to 0 until s equals to 9 in this case, so that we can find the probability of s is more than equals to 10. So the recursive formula is as follows. Probability is s equals to k is equals to 1 over 1 minus a probability x equals to 0, and summation of j from 1 to k. Okay, and the value of j can be seen here because we have modified the value of m to the value of y. So when we use the deductible, the m0 to 7 now become the size is only from 0 to 6. So our j will only work until 1 to 6 because k always starts from 1. So in order to find the probability of s equals to 0, we will be using the PGF formula of negative binomial distribution to compute the probability s equals to 0. So as we can see here, this is the PGF formula, where 1 minus beta star is the revised beta for the NP distribution, which is also a negative binomial. So we will use that 1 minus the new beta, which is v times beta, and then I9 is actually 0 because our k value is 0 here, and then 0 minus 1 power of negative r star. Our r star is equals to r, which is 6 here, and negative 6. So we will get the answer of 0.3349 for probability s equals to 0. So only for s equals to 0, because k only takes from 1 up to infinity, we have to use this PGF formula of the revised negative binomial distribution. So from 1 till 9, now we can use this formula. We can type it out in Excel to calculate the value of probability of s equals to k from 1 to 9. Okay, so 1 over 1 minus a, our a is at D26. Our a, we must use the a star because we are using the revised distribution. 1 minus a times the probability x equals to 0. In this case, our x is actually z, right? Because we are using the new distribution. So we have to take the probability z equals to 0 in this case, which is 0. So when the probability x equals to 0 is equals to 0, of course this whole part here will become 1. So for the upcoming calculations, we can exclude this and we can only focus on the summation from j equals to 1 to a specific value of k. So when k equals to 1, of course j from approach from only 1 to 1. So we can do a plus b 1, which is 1 here. A plus b time the j is 1, and then the k is 1. So k is 1, we can take from the Excel itself, which is at I10, and then times the probability x equals to 1. So probability x equals to 1, as we said just now, our x is this. So probability x equals to 1 will be here. Okay, the probability x equals to 1 is 0.5, and then j9 is equals to probability s equals to k minus j. Our k was 1 and then the j was 1, so 1 minus 1 is equals to 0. So probability s equals to 0 is the one that we calculated previously. So you can look at j9, which is this value. So you can include that in the calculation and press enter, you will get the answer. This method was applied to all the values of 2, 3, 4 until 9 in order to get probability for each value of s equals to k from from 1 to 9. Okay, let's say for 5, we will have k is equals to 5. So our j is equals to 1 until equals to 5. So later in our formula, we will have 5 different summations, as we can see in the formula tab here. So 5 different summations because our j will move from j equals to 1 until the value of 5. So we can see here that the power of D27 times with 1, and then in this case it times with 2 until D27 times with 5. This applies for all the other formulas, and when it comes to 9, it will have a longer formula, so we have to be very careful when computing the formulas in the formula tab. Okay, when we get all the formulas of probability s equals to 0 until 9, we can find the probability s is more than equals to 10, which is 1 minus probability s is less than equals to 10. So what I did was 1 minus the sum of all the probability of s equals to 0 to s equals to 9, and I get the final answer is 0.0312. So that's all from me for the explanation of question 4. Thank you.